This is an introduction to plots in IRSA Viewer and similar looking tools. Plots are sometimes called charts, but it's the same thing. Most, but not all, tables that you load into IRSA Viewer and similar tools have a chart that go with them, or a plot. By default, it's usually an RA deck plot. If it can't find an RA in deck, it will make a plot of the first two numerical columns that it finds. If you have more than 5,000 sources, it will not plot individual points. It will plot things as a binned plot like this. A grayscale plot, where in this case, because it's 76,000 points, some of these bins can represent up to 20 points. If you have somewhat smaller catalogs, individual bins may be only 4 points. If you have fewer than 5,000 points in your catalog, it will show each individual point in the plot. Even though this video is mostly about the plots, let's take a brief detour to see how it's represented on the images. This is discussed in more detail in the video on images, but you can see that it's representing the catalogs in cells. If you zoom in on the images, eventually it will show you individual sources. But when you zoom out, it shows the catalog in bins. If you want to see the individual sources in one of these bins, you can click on the bin and it will show you all of the sources in that bin. So let's go back and look at the plots. The first thing you're likely to want to do with these plots is change what's plotted. Let's go to the gears. You can plot one column against another like RA and DEC, or you can do simple mathematical manipulations. You do, however, have to use the columns of the catalogs exactly as shown in the catalog because the computer doesn't know any better. So you do have to match the column names exactly, whether it's capital letters, small letters, it all has to be exactly the same. If you don't remember exactly what these are, if you go to the magnifying glass, you'll get a list of what the columns are for the table in question. Depending on where you've pulled this table from, it may or may not have a description of what those columns are. You may need to go to the documentation associated with the catalog to learn more about what the columns are. This happens to be a WISE catalog, which I know very well. So instead of RA for X, I'm going to do W1MPro minus W4MPro, which is WISE 1 minus WISE 4. And then for Y, I'm going to do W1MPro. Because this is a color magnitude diagram, I'm going to need to reverse the y-axis. I want to put a label of W1 for the y-axis, and for the x-axis I'm going to do W1 minus W4. Apply. Now we have a color magnitude diagram. Let's do the same thing for the other catalog where we have more points. Go to the gears. For X, W1 MPro minus W4 MPro. For Y, W1 MPro. Reverse the y-axis. W1 minus W4. Apply. Close. So now we have a color magnitude diagram where we have 7,800 points. So some of these bins have 21 points. Let's go back to this plot where we have the individual points. These plots, of course, don't exist in isolation, especially where you've got individual points. If you click on a point in the plot, it will highlight it in the table and in the image right here. But this video is really focusing on the plots, so let's keep exploring what these plots can do. You can do some fairly sophisticated math. Here, I've got a catalog of objects that are all over the sky. You can see them distributed all over the sky here, and they've been binned up in various places here. Here it's got its default plot of RA and DEC. Let's change what's plotted. I've got a Gaia catalog here, so I've got distances. For the x-axis, rather than RA, what I would like to do is get a color, and I know that there's a color in here, but I can't remember what it's called. So I'm going to go to the magnifying glass, and then because this is a table like all the other tables here, I can look for columns that have BP in it. Now I can remember that, BP minus RP is the color. So that's what I'm going to do for X. And then for the y-axis, what I really want to do is 5 log D minus 5. But in order to do that, I basically need the G magnitude. So the column that I want is actually FOT G mean mag minus 5 log D. But what I have actually is parallax in milliarcseconds. So what I need is 1,000 over parallax minus 5. And since this is going to be a color magnitude diagram, again, I need to reverse the y-axis. Let's put some labels in here. B minus R and absolute G. Let's try applying it. Wait, it says we can't take the logarithm of a negative number. All right, so we need to find a solution. It turns out there is a column that's provided by the Gaia catalog that is a distance, but because I'm trying to demonstrate the capabilities of the plotting, I'm going to instead take the absolute value of the parallax here, just to demonstrate that I can do these nested calculations. Now I have to go back and tell it again, absolute G, and reverse the y-axis. Apply, close. So now we have an absolute color magnitude diagram from Gaia for the stars in this sample. You can see this works pretty well. We've got white dwarfs, giants, a pretty clear main sequence. Works great. Let's use this plot to explore what some of these icons do. These 3 icons here, you can see that they're sort of set off with slightly different formatting than the others. They control sort of, if you will, the mode in which you're using this plot. This by default is what's clicked. You can see the button is sort of pushed in. This is select mode, so that if I click and drag in the plot, I can select the stars that are likely giants or cancel the selection. I can click and drag and then filter the catalog so that now I'm left with just 70 stars that are likely to be the giants. I can then cancel the filters there. This mode allows you to just drag the plot around to go back to the default, hit the 1x. If you do this, it will zoom in the plot. To go back, again, hit the 1x. Even in select mode, if you have a magic mouse or a trackpad, I myself find myself accidentally zooming all the time. To go back, hit 1x. If you want to save the plot once you have it, click on the diskette. It tries to give you a default file name that makes sense, but by all means, change it to something that makes sense for you. This returns everything to the defaults, but let's not do that. Let's pin this plot. Pinning means hold on to this plot so that I can remember it. You can sort of think of it as sort of pinning it to the metaphorical bulletin board behind your monitor. Here, this is the active chart. If I do this, then this defaults back to RA and DEC, but I still have my color magnitude diagram here. For this, this icon brings up a pop-up so that you can put in filters this way. This is just another way of putting in filters, just like you can put in filters in the catalog, or for that matter, in the plot here. This, of course, is how you modify the plot. You've seen me do that. This makes the plot window big, which is sometimes useful. To go back, hit close. Let's explore some of the other options here. If you have a plot that you'd like to have with connected points or lines, you can do that. You can also change the symbol that's being used in the plot or the color that's being used. Maybe you don't like the blue or you don't like the transparency that's being used. You can see in the plot where the points overlap, it gets darker. If you'd like to do something different, you can change that as well. This is the relative colors. If you just click one of these swatches, it will change the colors, and this changes the transparency. You can also change the color map. So for example, in this color magnitude diagram, if you change this so that the colors are mapped to the parallax, we can apply it here. Now, the color scheme that's being used here is scaled by the parallax. You can also have the size of the points scaled by a value from the catalog. Let's do, I don't know, the size of the points scaled at the proper motion. That's a terribly uninformative plot. Let's get rid of that size map. Apply. You can also add grids to the plots. You can set the plot boundaries or change the aspect ratio of the plot. Let's use another set of 3 catalogs to explore the whole concept of pinning charts and why it's valuable. Here I've got 3 relatively large catalogs for 3 different regions of the sky that are kind of close here. All right, so let's change what's plotted. For the x-axis, let's do hmag minus kmag. And then for the y-axis, let's do jmag minus hmag. Apply, close. Okay, so let's pin this plot. Let's go to this catalog and let's do it again. HMag minus KMag, and then JMag, mag minus HMag, apply, close, and then pin it. And then for the last catalog, we'll do again HMag minus KMag, and then JMag minus HMag, apply, close, and pin that one. So let's see if we can make the plot region bigger and go to the pinned charts. Because they're pinned, I can look at all three of them next to each other, and it's the same plot. It inherited the title, which is the catalog from which it came. I could change the title if I wanted. Just because they're pinned doesn't mean I can't change them after I've made them. I can put the plots next to each other like this. When they're viewed like this, you're right, the axes have gone away, and the reason for doing that is just to make it easy to quickly assess them without having the axes taking up space. If you want to enforce that the axes take up exactly the same range each time, we can force them, you can force them to have the same range by changing the plot parameters, or we can view one at a time with the axes. Now, just because they're pinned, I want to emphasize that they're not immutable. So for example, I can come in here and enforce that they all have JMag and HMag and KMag by going through and filtering the catalog. Now I've filtered the catalog. Note that the plot is continuing to update even though it's pinned. Let's go to this one and similarly filter down the catalog and make sure the things that we're plotting all have JH and K values. Let's go to the third catalog and make sure that it too has values for all JH and K. So now all three of these plots have been filtered down to reflect the filter that I've put on the catalog. Now, when you're working with these plots, sometimes, especially if you have even more than 3 catalogs up and plots that go with them, it might be hard to remember which plot goes with which catalog. When you select the plot, this button right here will bring to the foreground the catalog that goes with the plot that you've selected. So that's the power of the pinned charts. You pin them so that they stick around, but remember that they're not immutable even when they're pinned. There are different ways that the plots are used in other IRSA tools. Like in the time series tool, you can make phase folded data, and because of the nature of the time series tool, you can click on points in the plot and it will go and pull the individual exposures from the NeoWise archive so you can identify exactly which epoch contributed to that data point. You can also get plots out of the catalog search tool. This one is the brightness of Neptune as a function of time. And just like the other plots, you can change what's plotted. In this particular case, maybe it makes sense to have the color of the points mapped to the heliocentric distance. Let's put that black body, apply, close. Now the colors of the points map to the heliocentric distance of Neptune. The last thing that I haven't mentioned yet is histograms. If I go back to the active chart tab here, I can click on the plus. Scatter plot is the individual points. Heat map is the grayscale where each bin contains more than one point. Histogram, I can make a histogram, say, of the errors in parallax, and I can control how it's binning that up. Okay, there's a histogram, and just like the other charts, I can do all the same things. I can, zoom, and I can pin it just like before. Now I have 2 pinned charts here. If I'm viewing one at a time in the pin charts and I have more than one, I have these arrows to navigate through the list. I didn't cover anything having to do with spectra because that's another video, even though it's also a plot. There's another video that covers the images and all the interesting things that you can do there and how it interacts with the catalogs. And of course, there is online help. If you go to the online help, there is a section specifically on plots.